Hello, this is Stepan Puchkov and Deep Grey Matter, a channel about the art of making decisions and the science behind it. I have started to get some feedback, and on a couple of occasions I was told that my stuff is a little bit overcomplicated. I can't help but agreeing. I am now going to fix it, and hence I've got two good news for you. First and foremost, we have gone through the most basic stuff, which we will be referring to later on. That is over, and I really encourage you to make sure you do understand it. And to that end, I am going now to go through all the stuff in more details and at a lower pace. Today, we will go back to the two systems theory and look at them in more detail.
So, how exactly do we think? How do we make decisions? The question is by no means straightforward. It is, in fact, very obscure. The mainstream theory is the theory of two systems, where system one is intuition, so it is responsible for fast decision making, and system two is deliberation or logic, which is responsible for decision making in a sequence of steps. The theory is really seminal, and it provides a very good insight into the decision making and thinking in general. So let us look closer at the two systems. System 1. It has a number of traits. First of all, it is fast. It doesn't take us any time at all to use it. Second of all, it is effortless, which means that we do not need to put any efforts into using it. It is used automatically and without any conscious effort. Then it is always on guard. This is a very important point. System 1 is always switched on, and this trait will have a consequence later. Then it is intuitive. By intuitive, I mean that we have generally no idea how it arrives to a decision. In Kahneman's parlance, it is an instrument for jumping to decisions. And finally, it is experience-based. And by experience-based, I mean that it draws on previous experience and very fast and again beyond consciousness compares what it sees now to what it has seen at some point of time earlier. To make a little bit more sense of all this, let's have a look at this picture. You have probably figured out that a TV set is falling down, thrown away from a window by a half-witted rock and roller, and somebody is walking by the building. Moreover, I think that you will agree that the TV set is not going to hurt the innocent bypasser, and on top of that, you instantly know that upon smashing into the ground, the TV set is going to be destroyed. You arrived to all these conclusions really fast. You didn't need to think a lot about it. Probably you didn't need to think about it at all. Then, correspondingly, it didn't cost you any effort. And in fact, you couldn't help but seeing and understanding what is going on in this picture. If we focus on the fallen TV set, you probably instantly knew that it is not going to hurt the bypasser and is going to vanish when it hits the ground. This was possible because from experience you know how objects tend to fall, and that objects like TV sets get destroyed when they fall from a considerable height. On the other hand, you didn't take into account that the wind might be strong at that place, and in this case the biparser could be hurt. So you automatically and effortlessly considered the most general case without going into too much detail. The discussed traits of System 1 lead to certain consequences. The fact that it is fast, effortless, and is always on guard means that in many cases, in fact in most cases, it is going to be the default processor for any incoming information, which means that any information we perceive through visual, auditory channels or else are first processed by System 1. The fact that it is intuitive and experience-based means that it is incapable of analysis. It only checks if the situation at hand is the same as a previously encountered one and can only say yes or no. That is the general rule. This altogether leads to two more consequences. System 1 doesn't allow for control or recollection of the thinking process. So once you have arrived to a decision, you cannot recall the steps through which you had gone to do so. And finally, and this is the most important point for our purpose, it is prone to systematic errors. The important word here is systematic. Let us recall the cognitive reflection test bat and the ball problem, where the bat and the ball together cost $1.10. The bat is $1 more expensive than the ball, and the question is, how much is the ball? The intuitive answer that pops up in the mind immediately is 10 cents, but it is incorrect. Let us see why. It's quite simple math, but still it took a lot of effort to resist the intuitive answer. So the correct answer is 5 cents, and correspondingly the bet is $1.05. Please note that no one, absolutely no one, replied something like 4 cents or 7 cents or 15 cents. The respondents either got it absolutely right and replied 5 cents, or, which happens more often, they take it wrong and reply 10 cents. This is the predictable systematic error associated with this question. Now let us move to System 2. Unlike System 1, System 2 is relatively slow. It takes some time to use it. Likewise, it takes some effort to use it, and the effort might be very considerable. Then, it is not always on guard. It needs to be switched on, and this leads to problems where it for some reasons doesn't switch on where it should. Then it is deliberative. So you deliberately use it. You go through a sequence of steps when you are using System 2. And finally, it is analytic. It is capable of drawing to previous experience, deliberately taking information from the memory, comparing it, analyzing it, making new information out of previously known pieces, and all this. Again, let's take it a little bit further and have a look at an example. Here we have a simple math problem. Say a grocery store has sold 10 oranges, 3 carrots, 8 lemons and 6 potatoes. How many times more fruit than vegetables have been sold? It is easier than the bat and the ball problem in the sense that you instantly know here that you need to translate the problem into math language. So in this case, the system 2 kicks in almost automatically, but bear in mind that it is not always the case. What are you going to do then? You are going to write down an equation, something like this probably. It was not very fast and it required some effort, although the problem is fairly simple. Then you are going to simplify the equation and to finally come up with the answer. What you have just done was deliberately going through a sequence of steps, and probably later on you will be able to recall the sequence of steps when you are asked how exactly you arrived to the decision. As with System 1, the traits of System 2 have consequences. First of all, it needs to win its right to act. Let us recall the bat and the ball problem. The question was fairly easy. What was difficult was to make System 2 act instead of System 1. The second consequence is that it can be overloaded. And it can be overloaded more easily than you can imagine. We will come back to this trait a little bit later in further videos, and I will show you exactly how it happens. Then it has an upside. It allows for control over the thinking process. When you're using System 2, you can always recollect how the argument went and track down possible mistakes, which results in that although it can err too, but it doesn't produce systematic mistakes. You can just miscalculate something, for example, but it is not systematic. It is much less predictable than errors of System 1. It may seem that System 1 is inferior to System 2, but it is not the case. System 1 is also very important because it allows us to make decisions fast, and we use it all the time. Otherwise, we would have need to deliberate over many and many routine actions, which would make us act like sloth. But that is at a price, and systematic errors of System 1 are going to be one of the main focuses of the videos to come.
This was Stepan Puchkov and Deep Grey Matter. If you found this video useful, like, share, subscribe. Between the devil and the deep grey matter, always choose the deep grey matter.